folks, I'm Keith Bowen, this is Hard Rock University, and today I'm going to describe another kind of sampling error that was a lot more severe than I anticipated it would be. So here I've got the bottle roll working properly now. I've got all the parts needed for the motor and everything's working real well. And the problem is that in analyzing this, you can introduce some rather serious errors, which I did, but I was able to correct for. You just take the jar out. Now this has been running for 2 hours now, okay? And what I was doing in the past is letting it run for the appropriate time. And I'd set it on the counter and let it settle for a little bit. Now since this stuff will not filter real well, I didn't bother trying to get it really well settled. Go ahead against the thing there. So you just take this, pour your sample in here. I was getting about 35 mils, somewhere around there. That's plenty for the lab. And as you can see, that is opaque. But in the lab, they put this tube in a centrifuge and spin it at high speed, and all that stuff settles right out, giving them clear liquid they could deal with. Now, the problem was that this now has about 35 milliliters less liquid in it than when I started. When I started, there was twice as much liquid by weight as there is ore. So what I was doing was taking a roughly equivalent amount of liquid, about 35 milliliters, that I use to rinse my pH meter, pour it in here, and that keeps the same amount of liquid roughly in the bottle at all times. Now, 35 milliliters isn't a whole lot, but when you're only starting with a half a liter, it's quite a bit. As a matter of fact, it's 7.5% of the total. What I forgot to take into proper account is, not only am I removing solution, I am also removing dissolved gold. That's where my problem was. Now here are the results of the analysis of the samples I took from the last test. And you will see that they're all very, very similar. This surprised the heck out of me. I dissolved a lot of gold at the beginning, and then everything just stagnated, plateaued. So I thought about it overnight, and I came up with the idea of checking to see how much of the gold did I take out with each sample, and how did that compare with gold that continues to be dissolved. And here is the table of those results. As you can see, the concentration stays almost the same. The amount of gold liquid, that's dissolved in that bottle, stays about the same. However, each time that I took out a sample, this is how much gold I took out of that sample. With that sample. So of the total, this is how much gold is missing at each sample time period. See what's happening here? Now if you add these two together and then divide by the total available, then you get these recovery percentages into solution. These are basically dissolution percentages, not recovery. Now we're looking at something pretty interesting. because 24 hours, got over 93% of the gold is in solution, and that is an acceptable number, definitely there. Now the question you might ask is, what is this number? Okay, and the answer is a little odd. You can take a volume or a weight times a concentration and come up with some weird unit. In this case, it is, let's see, where is it? Part per million milliliters. You're like, what the hell is that? It's only useful in this test. I took the parts per million of the solution concentration times the milliliters, which is 35, to get how much was being removed. And in this case, it's 500 milliliters, basically 454 mils, to get this number. Now you're like, well, that's just a weird ass thing made up, isn't it? Kind of, sorta, but it's made up exactly the same way for each bottle and each sample that was taken out, and as such they can be directly compared. And if you were to be multiplying ounces per ton times tons, you get ounces. And that would make sense. Okay, I can compare ounces to ounces. It's got a weird look to it, but don't let that throw you. Take the concentration times the amount, and as long as the concentration is in the same units and the amount is in the same units, you can then directly compare one to the other. And once you know how much is taken out with each sample, then you add those together. This is how much was taken out before this sample was achieved. This is how much was taken out before this sample was achieved. So you add those two together, gives you the total gold dissolved by this time period. And that's actually looking pretty good too, almost 80% at, what is it, 3 hours? Yes. So that's basically how you figure that out, and that's what you do. Now let me show you the difference that it makes. Now here is the graph. This is your 100% dissolved line there. See the difference between the raw data and the adjusted data? This looks like there's nothing happening over this time period. This shows you clearly there's something happening and what exactly it is. And that may also explain some of the other flat line plateaus on the previous graph too. Just not properly correcting for the variables. My mistake. Luckily it looks so weird here that I went back and looked at it, and now I corrected. And now I have a procedure that makes this real simple. Let me show you what that is. So this is how I solve the problem, make the calculations easier. I predetermined that I wanted 5 samples out of this test, using the specific chemicals, the specific ore sample, and the specific grind. This is mainly, I'm testing grind here. I'm getting pretty darn good recovery on the fine grind. So this is a different ore. This is lower decline dump, and this is ground to 20 mesh minus only. So what I did here, I put 5 samples. They're all the same. And each time period, like this is now the 4-hour one, that's the next one, there's 2. I'm going to let that continue to dissolve, because when this is all over, I'm just going to recover the solution from all of them for other kinds of testing. In 4 hours, I'll take this one out of circuit, take a sample out of it. Then 8, then 16, then 32. They're all going to have exactly the same thing. They're only going to have one sample taken out, and that's actually going to get analyzed for concentration, and therefore there's no adjustments necessary. So that's how I've solved the problem for now. But you need to be very careful not to make assumptions, especially of, well, that's probably not going to be enough to make a difference. Do some quick calculations and see, and you may find you're radically wrong, as I was. But at least when you look at things, things don't look right, start digging in, figure out what went wrong, if anything, and go from there. And then you can proceed to the next step like I'm doing here. So things are going well. We'll see how this test works out next week. Happy prospecting and keep it safe out there.